In this three-part video series, we'll explore simple linear regression models. In this first video, we'll motivate the topic and explore appropriate visual summaries, scatter plots in particular. Consider some context. Scientists in Antarctica observed a sample of 344 penguins and recorded characteristics such as their body mass in kilograms, their species, and the length of their flippers, or arms, in centimeters. Below is a snippet of their data, where each row corresponds to a different penguin. We can start our penguin analysis with some univariate research questions, that is, questions about a single variable of interest. For example, suppose we're interested in body mass in particular. Then we want to know what's the central tendency of, or typical body mass. How much spread or variability is there in body mass from penguin to penguin? To this end, a histogram demonstrates that the typical body mass is around roughly 4.5 kilograms, though it ranges between roughly 3 kilograms and 6 kilograms. The next natural follow-up question is, why does body mass vary from penguin to penguin? Is it related to other penguin characteristics, such as species and flipper length? Might we predict or explain body mass using these characteristics? The questions here are multivariate in nature. They get to the relationship between body mass and other variables, not just the univariate behavior of body mass alone. In studying relationships between two or more variables, you might have noticed a distinction between two roles. The response variable, or outcome variable, commonly denoted as y, is the variable whose variability we would like to predict or explain. Here, the response variable is body mass. The explanatory variables, or predictors, commonly denoted as x, are the variables that we might use to explain or predict the behavior of the response variable, hence the terms explanatory and predictors. Here, possible predictors of body mass include flipper length and species. In general, a response variable y can be quantitative or categorical. A predictor x can be quantitative or categorical. And we can use just one predictor or multiple different predictors in the same analysis or model. For example, we might model body mass by flipper length alone, by species alone, or by both flipper length and species. But we're going to start small, in the simple linear regression setting. Specifically, we're going to study the relationship of a quantitative response variable with one quantitative predictor. For example, we'll seek to answer, how is penguin body mass y related to flipper length x, both variables in this question being quantitative. As we did when studying one variable at a time, we'll start with visual summaries of this relationship, scatter plots, and follow it up with some numerical summaries, correlation, and simple linear regression models. Let's start with visualization. Recall that the appropriate visualization depends upon our variable or variables of interest. Here we have two quantitative variables, and we can represent each in terms of their quantitative scales by assigning each variable to its own axis. Conventionally, we always put the response variable y, here body mass, on the y-axis. With the axes set up, we next want to use some geometry to represent the penguin data points on this blank canvas. With data from two quantitative variables, we can utilize a scatter plot. Here, each dot represents a single penguin. The xy coordinates of the dot are the penguin's observed x and y values. For example, the penguin highlighted here had a flipper length x of roughly 22 centimeters and a body mass y of roughly 6 kilograms. Now that we've constructed the scatter plot, let's explore what it tells us about body mass versus flipper length. To begin, we can focus on the trend in the relationship, specifically its direction and form or shape. Here, the direction of the relationship is positive. The longer the flipper, the more a penguin tends to weigh. The form of the relationship is linear. The individual data points appear to vary around a line. Putting this together in context, body mass tends to linearly increase with flipper length. Next, consider the degree to which the individual penguins vary from the trend, hence the strength of the relationship. Here, though the data points don't fall directly on the line, the body masses of individual penguins vary relatively little from the trend. This indicates that the relationship between body mass and flipper length is strong. That is, flipper length is a good predictor of body mass. Finally, we should check for outliers. Here there aren't any extremely unusual points or penguins that fall far from the trend. The scatter plot provides nice insight into the shape and strength of the relationship of body mass with flipper length, but it doesn't provide specifics. For example, how strong is the relationship of body mass with flipper length? How can we more accurately describe the positive linear relationship? For example, at what rate does body mass increase with flipper length? How can we more accurately predict a penguin's body mass if we know its flipper length? To answer these questions, we need some numerical summaries.